So we're going to continue with those. Vertices of T0 and pin 0 with major axis length of 4. Yep. So the major axis length tells me A is 2. So we do have that. Now, the only other value we need to find is the value of B. Yep. Is our vertices is our H plus or minus A comma K, or H comma K plus or minus A. So our A value is connected with our vertices. Now that tells us, it does tell us something, because it tells us that the center of this, one of the values is going to be at 0, because it's H comma K, and our vertices is either H plus or minus A comma K, or H comma K plus or minus A, depending on which direction the major axis is going. So here we know it's going along the X, because we're going from 2 to 10. And it's really telling me that H plus A plus or minus A is going from 10 to 2, and we know, actually, make sure I wrote that down right, because the major axis length is minor. That's, Lord, that's why it doesn't make sense. That's why I was staring at that, looking at that wrong. Minor axis length is 4. Okay, because I was staring at that, I'm like, well, vertices is only going to give me A, because I know wherever H is, we're either adding it or subtracting it to get to 2 and 10. So most likely when we add A to it, we should get to 10. When we subtract from it, we should get to 2. Which really means we can use a system that we actually just set up and we can add them together. H plus H is 2H. A plus negative A is 10. So the center is at 6, 0. Now, what we called A is actually B, which is 2, because the minor axis length is 4. We have to cut it in half because it's going above and below the center, and it gives us 2. Now, A, in our case, so we're going from 6 to 10 or 6 to 2. 6 to 10 would be, because 6 plus 4 is 10, 6 minus 4 is 2. So our A and B values are 2 and 4. Our center is at 6, 0. So when we look at the overall equation, x minus what? Squared. Now the other one we're going to have y minus, we can just put y squared. Now, major axis is going which direction? With the x or with the y? Because where did we get x? We got it from the 2 and 10, which are connected with the x. So it's going to go along the x, and our value of a is 4. 4 squared is? B is going to be 2. Yep, 4 is equal to. And if we're looking at the equation where it says center, or kind of vertices is x plus or minus, or h plus or minus a, it's going with the x. Depends on where we're putting it. Since the x values are changing kind of for the vertices, major axis is with x. If it's changing for the y's, it's with y. Because the vertices are always going to be along the major axis. Vertices are always going to be along the major axis. They're not going to be along the minor. Does that make sense? Yes. I have a feeling most of this here makes more sense once y'all have done it at least once. Okay. We're going to look at 2 more. One of them is going to be, we're given the foci of 0, 0, and make sure, yep, 0, 8. So these are our foci, which means we're dealing with the value of C. Most likely. And the major axis, and this time it is major axis, length is 16. So we're given the focus and the major axis length, which are on the same line. Because again, in our picture, C is just from the center of the circle to the foci. And the major axis length is the line that goes through both foci to the vertices from the center. Now this tells me that my A value is 8, because the overall distance is 8. Now the foci are exactly evenly placed. They're exactly the same distance from the center for either side. So if I go from the center to one foci, or from the center to the other foci, center is always in the dead center. So if we want to find the center, we just need to find the midpoint. Because we can add the two x values together and divide by 2. Well, 0 plus 0 is still 0. Divided by 2 is 0. 0 plus 8 is 8. Divided by 2 is 4. So our center is 4, which really tells me h and k. Now, it also means C is 4. Because C is the distance from the center to the foci. So from 0, 4, if I add 4, I will get to 0, 8. Subtract 4. Yes. Goes 4, 8, 2, 48. Now, the b value is only going to be put into the bottom part of either one of the fractions. And it's going to be what? Squared. Because we have in the bottom, depending on which one's accustomed to, either x squared or y with x or y, a and b are both squared, yes? So I could simplify the square root of 48. Yeah, because if I simplify it and then square it, I'm back to 48. If I leave it as square root of 48 and square it, I'm at 48. So for this here, there's no real point in simplifying it further than this here, unless it's specifically asking for this value, then they're going to most likely want you to simplify it. If they're not, we can just leave it as this here. Now the next question is, which direction are we going? Is it being stretched along the x or the y? My hand motions just threw y'all off so bad.
Y, right?
It is the y. Because the foci are along the major axis, which is along the stretch. So since the foci are along the y, it is going to be along the y.
My brain was like,
Yeah, no,
this is not y, this is x.
Yeah, I went horizontally and saying y, vertically and saying x, threw everybody off. Now, so our a value is going to be with the y, and I always put it second. Since a is 8, a squared would be 64. Since b is the square root of 48, b squared would be. Now, x is going to be minus 0, so we just have. And for y, we have y minus equals 1. Now, the order in which we have these really doesn't matter because of it being an ellipses and everything, because they're both plus. Now, when we get to hyperbola, hyperbola is the next section that we'll cover, and it deals with minus, which is a little bit easier actually to deal with because whatever a is, the major axis, will go with the one that's positive. So the a value will always be in the first place, in the bottom of the first fraction. B will always be in the bottom of the second fraction. And it will always line up that way because we won't have both fractions being positive. The minor axis, the one that the minor axis is attached to, will be subtracted. So it will be minus. So with hyperbolas, in the bottom of the fraction, the two numbers in the bottom of the fraction, a is always going to be first, b is always going to be second for hyperbolas. But for ellipses, whichever one's bigger. So if we're actually looking at the equation, and I think we did this in Algebra 2. Did y'all have Algebra 2 last year?
Yeah.
So we didn't cover this.
Yeah, because we had
COVID. But in years past when I cover it, especially if we're looking at the equation, we deal a lot with just the equation, picking out the parts of it. It's really looking at which number is bigger. For ellipses, it's which number is bigger. That is our A, our major. The smaller is B, our minor. So we can look at it just based off the equation. But this is it here. Questions on this here? Now we do have one more that we're going to cover here. So, last one we'll cover. Center is at 2, -1. Vertex. Two, 1/2. Minor axis length is 2. Yeah, they like 2. Because luckily 2 is divisible by 2. Always. Okay. Now, it did not give us the vertices, but it did give us the So, that's actually kind of close to the same thing. Now, really what we need for this equation, if we're finding the equation, is actually not too much. Since the center is 2, -1, well, it would be x minus 2 squared would be 1. And it would be y minus -1, but the negative and negative make a positive. Yeah, so we rewrite it as that there. Now, the only other things we need are A and B. If the minor axis length is 2, B is 1. Now we need to find the value of A. We need to find the value of A. Now, when we look at this here, the vertex, as we said, is always along the major axis. Now, if it was along the minor axis, we would not be able to get anywhere. Because what that would tell me is if the vertex was along the minor axis, well, they gave me the minor axis length, it would just give me the value of B. It wouldn't actually get me anywhere. Does that make sense? Because we need something with A. Center doesn't tell me anything about A. It just tells me where the center of this ellipses is. Minor axis tells me the value of B, that length. Vertex, which again, properties of vertex, it is on the major length. So, well, that's not changing. So it is along the X or the Y. It's going to be tempting to say X. It is the Y because which direction is it changing? Oh. Along the Y. Because in my head, I was actually about to say X because it's tempting to say, okay, well, we're emphasizing this here. But really what we're saying, if we were to picture it on an actual graph, because we're over at 2, because I think it was 2, -1 down here. Erase that draw point. Because this is where we said the center was. Now, our point for the vertex is at 2, 1/2. So that means it's going this way, so the major is along the y-axis. Does that kind of make sense? So sometimes it's good to picture it in your head and draw it out. Wrong way. So that means B is going to be with X. Now we just need to find the distance from -1 to 1/2. Well, the distance from -1 to 0 is not 1/2. Yeah. Huh? So we're finding the distance from -1 to 1/2. Well, the distance from -1 to 0 is, the distance from 0 to 1/2 is 1.5, or we can say 3/2.
That's what I meant. Okay. It actually was what I meant.
So we would have it being 9/4. And I think, yep, that's what I thought. So we have this set up here. Now we can't leave it in this form because we cannot have a fraction inside of a fraction. So we can flip this here, which would be, here we would have x minus 2 squared plus 4 times y plus 1 squared divided by is equal to 1. Now, we can't multiply the entire thing because this equation has to equal 1. Hyperbolas are the same way. They have to equal 1. We have to have them set up in a form so that they equal 1. Does that make sense? Yeah. And this is about as far as we're going to go here. Okay? No. Okay. Okay. So I did not want to stop the recording yet. just so that I will have this back up here in a second. So this here is the assignment. Find the standard equation of the ellipses with the given characteristics. So standard equation for 9 through 16. 19 through 30, find the standard equation of the ellipses with the given characteristics. So in all of these, you're finding the equation. You're not graphing, you're not explicitly saying what is the major axis, what is the minor axis, what is the center, what is the vertices, what is the foci. You're not finding any of that there, you're just giving the general equation. Okay.